Hello and welcome to my video on chapter 3 and 4, lesson 6, the laws of logarithms. So all of these laws come from power laws or exponent laws, and these are what we can see from Math 10C in the Math 10C formula sheet. And so you should already know all these, and they're also kind of from grade 9 math, and so again, you should know these, but we're really going to be focusing in on this one, and this one. And so these three laws, and yeah, I mean, like these other ones do come up, especially this negative one is pretty important. But those three laws give us our three main log laws. And so we're going to be using these laws to come up with our laws of logarithms. Okay, so what we're going to do is first take a look at the product law. So here is the product law as written for exponents, which is that if we're multiplying two things with the same base, we add the exponents. And so you can see this example where we did 10 to the 2 times 10 to the 4 equals 10 to the 4 plus 2. So this is 10 to the 6. All right, so this is fantastic and great. Since logs work in reverse, we can talk about the exponents, right? They're equal to the exponent. So if we look at this example, it's really 2 plus 4 equals 6. So this is a 2, this is a 4, and this answer is a 6. So that's all that it's saying is 2 plus 4 equals 6. So it's kind of obvious, and yet maybe not right away. So the rule is, the log law is here. If we're adding two things with the same base, we multiply the insides. So we're multiplying the answers, just like the answers were multiplied right at the beginning up here. The answers are being multiplied, and so the exponents are being added. Well, that's what's happening here. These are the exponents, and then these are the answers. So the answers are being multiplied, the exponents are being added, just like before. All right, let's take a look at the next law. The next law is the quotient law, and I hope you won't be too surprised by this, but it's basically the exact same thing except a division version. And we know for exponents that if we're dividing two things with the same base, we subtract the exponents. And so we can see this result happening here. 4, 2, subtracting gives us 2. So again, same sort of idea. These are both exponents, right? They equal the exponent. And so this is our final result for the exponent, right? And so here's our overall log law. And again, just like before, we can say that these are exponents, and this is the answer. Or, sorry, not the full thing down here. The n and the m are answers. Okay, so there's our second law of logs. We have a product law, we have a quotient law, we have a power law. So again, with exponents, if we have a power to a power rule, that means we're multiplying the exponents. And so this is our original exponential law, power law. And so what we can do is we can use the basic definition of a log here in order to kind of prove this statement. This is a little bit harder to tell prior to this, but if we take a look at this example, what we're doing is we're doing a log of both sides. So we're taking the log of the original, and we're taking a log of the answer, and we're going to slowly rearrange and prove that logs kind of do the same sort of thing. So since we took a log of both sides, now we can notice that this squared is kind of sitting on the inside there. And this answer gives us 8, right? Because the base is already 10. So this one will give us 8. And this inside here will give us 4. And so how do we go from 4 to 8? Well, we just need to multiply by the 2. And so that 2, that exponent, came out in front to make that happen. So it's equivalent to saying this equals this. So, therefore, this is our logarithm law, which is basically saying that this exponent can go out in front. So it multiplies, right? So it's a power to a power, right? This is our answer on the inside, but this is a power of the answer. The answer itself was 10 to the 4. And then it has the n to the exponent, right? So what we're saying here, n is the second power, and then this whole thing is the first power. So again, we're multiplying the two powers, and so it must be a power to a power, which is what we're seeing here. Kind of maybe not as clear as the last two, but hopefully that kind of makes some sense. Okay, and the last rule that we learn is, at least I call it the change base law. And so if we start with the basic definition of a log here, what we can do is we can flip that by just changing it into exponential form. And if we flip it, then we can take the log of both sides. By taking the log of both sides, and we can use any base, by the way. So default is 10, but you could use any base you wanted here. Now we can go ahead and use the power law before to move this out in front. And then we're going to divide this across the equal sign. And so when we do that, we get this result, which is equal to y. Well, hold on a second. We already know what y is. Y is up here. It's equal to this. So we can just write this equals this. And that's how we get our change base law. Okay, and that allows us to go from any base to any new base. I don't really have this process memorized. I would just worry about the fact that b is the base, and so it ends up in the denominator. I mean, I think it's easy to remember base is lower than the other part, and so just keep track of that, and you're good to go. Any other base for a works. Okay, let's go ahead and use these 4 different power or log laws to solve some questions. So here's the first one. Determine the value of the following logarithms. If you think you can do these questions, I recommend you pause the video now, try them out yourself, then press play. So this is a very simple situation where we're going to get 150 divided by 6. Because they're subtracting, we're using the quotient law. So this is log of 5, log base 5 of 25, which is 2. Without that process, it would have been actually very difficult or impossible almost to get any sort of reasonable number without our calculator, right? But because I was able to subtract / divide, I was able to simplify it and solve it by hand. Okay, and you're going to see that with these next couple. So same sort of thing here. This is log base 2, or base 10 by default, and then 2 times 50 because we are adding. This is the sum or product law. So this is log of 100, and oh, look at that, it's 2 again. I'm very creative because it's got a base 10 and the answer is 100, so it must have an exponent of 2. Okay, looking at our next one here, we are going to use the power law. So log 3 to the 4, log 81. And unfortunately, this one, it's not really going to be doable without a calculator, but you can tell that because it's log base 10, if it was a 10 here, the answer would be 1. And this is log base 10 of 100, the answer would be 2. So it's closer to the 2. So I mean, I can make an estimate just like I could with like, if you had like a square root of a 30, right? You could make an estimate and say that it must be over 5. So maybe like 5.3 ... right? You can make an estimate here and come up with a number. But let's go ahead and plug this in. So log 81 and 1.9. So my estimate was close, but not quite perfect. And I mean, there's also like obviously more decimals after the 1.9. Okay, so there's a benefit to all these laws of logarithms. Those ones above, I mean, you're just plugging it in your calculator anyway, so whatever, it's not a big deal. But here are some where I could ask you these questions on a test, either as a written response or even as a multiple choice, and it would, or numeric response. This one here would lend itself to numeric. This would lend itself to multiple choice, and you'd still have to go through it a little bit. So we're going to go through this and write it as a single logarithm. So again, I recommend you pause the video now and see if you can try this on your own. Okay, so this is going to first use the power law to move those numbers into the logarithms. Then we're going to use the quotient law in order to write it as a single logarithm, which looks like this. Fun fact, if you wanted, you could, I think you should probably just end it there, but you could go like this, which means you could write it like this. I mean, it doesn't matter. This is probably a perfectly reasonable answer, but the second one is kind of fun to see as well, depending on, the example question. And this one doesn't matter. Okay, this next one, let's take a look. So first of all, we're going to change the 1 power to write it inside the logarithm. So there it is. Now we're going to write it, but with all of the parts that are adding as multiplication, i.e. on top of the fraction, and anything that's subtraction or negative, we're going to move it to the bottom of the fraction. So it looks like this, and now we can simplify because there's an x on top and 3 x's underneath. We can write it like this. All right. Another 2 questions to take a look at. These are slightly different. They're kind of fun ones for numeric response. If log A equals 5 and log B equals 3, evaluate the following. So at first it looks like, what the heck are we doing? But if you try some stuff here, you might be able to figure it out. Pause the video and try it yourself. Okay, when you have one of these questions, my hint to you is simply split it up. So that's what we're going to do here. We're going to split it up until it becomes obvious. And I think you'll see that it's basically obvious right now. So these 2 log parts, so log A is 5, log B is 3, and log 100 is 2. So we can now state our final answer, which is 2 plus 15 plus 6. So that's 21, 23. So like I said, lends itself to numeric response. Okay, let's try this next one and see how this one works. Oh, I made a mistake. I wanted to have this as that. So maybe pause the video now and try it out yourself and see if you get the same answer I do. Okay, so first of all, what we're going to want to do is split up each of these statements. Anything that's on top of the fraction is addition. Anything that's on the bottom of the fraction is subtraction. Okay, now we're going to put that together. In this case, I'll just leave that for now. I'm going to put the 2 log A minus 3 log B. And again, hopefully at this point it's somewhat obvious. So 2 times log A, so 2 times 5, minus 3 times log B, which is 3. And then log of 0.101. You should recognize that 0.01 is like saying 1 over 100, because this is the tenths, this is the hundredths place. So literally that's what that's meaning. So that means it's 1 over 100, or 1 over 10 to the 2, or 10 to the negative 2. So our answer here is negative 2. So putting this all back together, we have negative 2 plus 10 minus 9, which all equals negative 1 as our final answer. All right, I hope this video helps you better understand the concept of laws of logarithms, as well as how they all came about based off exponent laws, as well as some example questions. Hope the video helped, and good luck.